Okay, Zay, I want to tie in some things that we covered. Um, and in 8.2, uh, you, you want to sort of make sure you're clear on a few things. One is something called the roots of a quadratic equation or quadratic function. The other is the axis of symmetry. And the third thing is the vertex. The last time we spoke, you sort of talked about the formula for one of these. So I just want to make sure we're clear. The one thing you want to remember is what a parabola is. And we spoke about, or we mentioned that before. Anytime you have this form, ax squared plus bx plus c, anytime you have that form of a quadratic equation or function, you're going to get a parabola, 9 times out of 10, I guess. And a parabola, just sort of the shape of it, it's either going to be like this or it's going to be like that. So depending on if it's looks like a smile or a frown, depending on how you look at it, that's based on whether or not the A is positive or negative. So in this case, the A would be, I'll say A is going to be greater than 0. And in this case, A is negative, so it's less than 0. Okay, so and that's what the parabola is going to look like. Now, in terms of how slim or wide the parabola is going to be, that's going to be based on that again is going to be based on A in terms of whether it's, but not whether it's positive or negative, but whether it's greater than the number 1 or less than the number 1. So if it's, let's say it's an 8, if you have like 8x squared, well, that's going to be super narrow. If you have something that's, say, 1/8, which is less than 1, x squared, well, that's gonna have a wider curve to it. And the same is true if this were negative and this were negative. Now you're looking at something like this, or you're looking at something like that. So that's basically what's going to happen in terms of this is your quadratic and all the things that the A determines about the parabola. Now the other thing about a parabola is it's symmetric in the sense that if you could find the exact middle, you could flip it. If it were on a piece of paper, you could flip it and you get an exact opposite. It's kind of where you can, it's symmetric. It's both sides would be the same. So what you want to do is when you're looking for, so a lot of times what you're trying to do is find out if I were to graph a parabola, depending on where it is, let's say the parabola looks like this, okay? The middle would be something like that. It would sort of look like that. And what happens is when you're trying to find that middle, that absolute middle, that's called the axis of symmetry. That's the second thing I actually want to talk about. But that's called the axis of symmetry. Okay? So the axis of symmetry is right there, right in the middle. And there's a formula to find the axis of symmetry. But before we even get there, and I'll come back to this, I wanted to state that because a parabola sort of curves, let's say this board doesn't erase well, so it's hard to, I just keep moving over until I have to erase. Alright, now you already know that this is the x-axis and the y-axis, right? Really, axis is just kind of a straight line or a plane. And so when you hear axis of symmetry, it's just whatever that straight line is that cuts a parabola in half. But anyway, if this is your graph, and this is your x-axis and your y-axis, and you have a parabola, and let's say we're going to draw a parabola, in some cases, the parabola is going to cross this x-axis. Not in every case. In some cases, the parabola could be way up here, right? But if the parabola does cross the x-axis, if it does come down and either hit just once, or let's say we had a parabola that went like this. Okay. If we had a parabola that went like that, then you can see it crosses the x-axis in two places. Crosses here, crosses here. Those two places where the x-axis where the parabola crosses the x-axis, those are called the roots of the equation, or the roots of the function. So the roots are wherever it crosses the x-axis. Okay. Now the way you sort of try to calculate what the roots of the equation are is the one thing that you'll notice about the x-axis is the x-axis is the point where the y value is 0. Right? So at this point, whatever this x is, who knows, but we know that the y value is 0. The same is true here. We don't know what the x is exactly, but we know the y value is 0, because this is the y axis. So if you can find out where y turns out to be 0, then you can find out the roots of an equation. So like, let's say we had, I'm wondering, can I do that? Maybe not. Let's say I'm going to have to erase. I hate this. Oh, before I even erase that. Let's say this is your parabola, or it doesn't matter, but let's say this is your parabola. And this here is called our axis of symmetry. It's that line in the middle. Well, one of the points on the axis of symmetry would be sort of where the axis of symmetry meets the parabola. Okay. Now you want to find, there's a word that you use for that point. If a parabola is like this, the lowest point is called the vertex. If the parabola is like this, the highest point would also be called the vertex. So it can be the lowest point or the highest point. Just depends. Now, the way you find the vertex is first finding what the axis of symmetry is. So you have to figure out the axis of symmetry before you can find what the vertex is. Okay, and you told me this before. The axis of symmetry actually has an equation. So the axis of symmetry, negative b over 2a. That's how you find the axis of symmetry. You find out what the a and the b are, and it's negative b over 2a. Now once you find, and that's always going to be, so it's always going to be in the form of this, x equals some number, whatever that number is. The axis of symmetry. And the reason is when you graph a line that's like this, the axis of symmetry is always going to be a vertical line. When you graph a vertical line, it always comes out as x equals some one number. And the reason is, if you were to graph this line, if this were your line, you basically say it doesn't matter what the y is, x is always this. Doesn't matter what the y, how high the y up is, x is always this. Don't matter how low you go, x is always this. So it always comes out, the axis of symmetry always is in the form of x equals some number. And once you have what that number is, you plug that number into the original equation, and you'll get a y value. So once you plug that number into the original equation, you'll get a y value, and that xy pair, the x that you get for the axis of symmetry and the y value, those combine to give you the vertex. Okay? So let's, again, we use this formula to get the axis of symmetry, and it's going to give us just a number for x. But that is the axis of symmetry, the line for the axis of symmetry. And if you take that number and plug it back into the original equation, then you can get your xy value to give you the vertex. And then you can kind of figure out what it's going to look like. So those are, I'm not actually even doing any problems in this video because I don't know how much time I've used. That's over 10 minutes. So those are three things: the roots, the axis of symmetry, and the vertex. 10 minutes, 50 some seconds.